Hello, welcome back to my channel. Today our topic is Kotlin Coroutine in Android. Coroutine is basically another option to work on thread. Coroutine manages background threads to handle long-running tasks elegantly and efficiently. By the way, this tutorial is completely beginner friendly. If you have no idea what coroutine is or you don't know anything about background threading on Android, then this tutorial is for you. I will show you the basics of Kotlin Coroutine throughout a very simple app where you would learn how to use coroutine in your Android projects. This tutorial consists of coding and theories on coroutines. Before explaining the coroutine, I would like to give a short brief on threading. Mobile devices have processors to process our data. Nowadays, most of the mobile devices have multiple processors and each processor runs concurrently. This is called multiprocessing. On top of that, operating system imposes more than one threads to execute tasks. This is called multi-threading. Now in Android, a foreground thread named main thread is responsible to all UI related stuffs. All the UI related things like creating a new UI or changing text of a text view happens on the main thread. That's why it is sometimes called UI thread. This main or UI thread also is the default thread, which means unless you create any other thread by yourself, all those tasks will executed in the main thread. This brings a potential challenge. Now, if a task like fetching data from the web or accessing internal SQLDB or SQLite database, which are long-running tasks, if this task appears and if you block the main thread for too long, your app may freeze, may showing application not responding dialog, and eventually get crash, which will cause a bad user experience. Kotlin Coroutines performs long-running tasks away from the main thread without blocking the main thread. With the help of coroutine, we can perform long-running tasks in a background thread, get the result from that thread, send it to main thread, and thus make our code non-blocking. So enough talked, let's jump into the code and see what problems we are going to solve today using Kotlin Coroutine. I have created a fresh new Android Studio project in my Android Studio, and if I go to the activity main XML, and here we can find one button and one text box. So I give it a little margin here. Okay. Now we are not doing much in our in this project because it is all about coroutine, and the app is very simple. It contains only one button and a text view. Now going back to our main activity, and first we will simulate a long-running task and what a long-running task could look like. But before we creating any long-running tasks, we need to add dependencies for coroutine. Into Gradle, build.Gradle, and we need to add these 3 lines. By the way, I have put the dependencies in the video description. Please you copy those dependencies in your project if you want. Now we give press sync now, opening our main activity, and here we will simulate a long-running task. So we name it we create a function named fun long running tasks, and say this function, from this function we will update our this text view. Okay, so we will just set it the text result dot text. We will simply put it and name it that what should say response. response. Okay, now this thing will work fine without any problem, because but if we put a delay or thread.sleep, in this case we can say that thread.sleep, and we sleep it for 2000 millisecond, that is 2 seconds, and when this function will be called, the first line will be executed this thread.sleep. That means our function will wait for 2 seconds and or 2000 millisecond and then press this line. So we are considering 2 seconds as a long running task. Okay, so we will call it from that. So button on click dot set on click listener and be long running task. Okay, and run our project. So in our emulator we see a button, and when we press the button it's freezing, and after 2 seconds it is showing the response. So when I once press this, the total scene is freezed, it is not working anymore. Okay, let me change a little so we can understand it more clearly. So it will be something like text, and we will create a new line. So for each response we will create a new line. So it's like the previous thing, the text result dot text dot toString, and we will create a new line and create the response line. Okay, response text. Now running our project again and opening our emulator, and when I press the click, wait for 2 seconds, the whole UI is freezing for the 2 seconds, and click and another response is adding as new line. So the thing is that it's a long running task, it's wait for 2 seconds, and when I click, the whole entire activity is freezing. You see, it's not working anymore. Okay, when I press it, it's freezing, and after 2 seconds it's responding. Okay, so this is definitely an issue, and we are going to resolve. We will use Kotlin Coroutine to do the long running task in the background thread and take the result in the send the result to the main thread and show it in the main. Now at this point you may thinking that coroutine and thread are same, but in reality they are not same. Although coroutine works like thread, but coroutine is not thread. Thread is mainly managed by the operating system itself, and coroutine is managed by a user space level by Kotlin runtime. When a coroutine is created, that coroutine is assigned to a thread. It remains to the thread until the coroutine gets suspended. I will discuss about suspending coroutine in some minutes, but for time being, assume that coroutine remains to that thread until the coroutine gets suspended. After the suspending, the same coroutine can resume to another thread. Thus, coroutine doesn't belong to a particular thread. Also consider a coroutine has some jobs to do. A coroutine may have multiple jobs to do, and a thread may contain multiple coroutine. Let's get back to code and see how to create coroutine. From our code, we got to know that long running task is a long running task function, and it lets the function to wait for 2 seconds because of thread.sleep. But we won't use thread.sleep anymore because it is a notorious thing. So what does the thread.sleep for 2 seconds do? So when we write this thread.sleep and give it a time, So the entire threads is blocked, and the entire thread takes time for 2 seconds, which is not accepted, because we may have some coroutines, may have 50 or 100 coroutines. So when we write this kind of thread.sleep, it will make the whole thread blocking. Okay, instead of this thing, we can write the coroutine style, that delay for 2 seconds. What does it do? This simply, we haven't created any coroutine yet, but for time being we assume that this delay only belongs to this coroutine number 1. So writing this delay for 2 seconds actually hold this coroutine. It has no effect on coroutine 2 or any other coroutine or in the thread. So all other coroutines will work fine, only delay that coroutine. Okay, now it is showing an error. When we write the delay, it is showing an error that, and saying the suspend function delay should be called only from a coroutine or another suspend function. So the Android compiler is saying that we need to, if we use the delay, we need to make the function as suspend. So we make this function as suspend, but creating this, making this function suspend will make the same error here. So what does the suspend do? Before fixing this issue, we will see what does the suspend do in the coroutine. Let's see what happens when a coroutine gets suspended. A coroutine can be either running or suspended. Let's assume we have 3 coroutines running in a thread. Coroutine number 2 is a long running task. We suspend this coroutine. Here, suspend means instead of waiting for the code to execute that coroutine or function, transfer to another thread by Kotlin runtime. A suspend coroutine is not associated to any particular thread. It can resume to another thread and may result back to previous thread. Coming back to our code, I have forgotten to delete the line, remove the line. I just removed the line. We do not need thread.sleep anymore, and we will create a coroutine to get rid of this error. So we will create a coroutine, but first we will create a scope for the coroutine, whether the coroutine is in main or IO. So val dot scope, and it will be, we'll create a coroutine scope. I will explain everything in a while, so don't worry. Coroutine scope, and it will be dispatchers.io, and okay. So what does this line do? Actually, we want to run this long running task no more in our main thread. We want to do it in our in any other background thread. For this, coroutine offers us four kinds of thread. One is IO. IO is basically used for input output operation, or network related calling, or SQLite database operations. So this is for IO, and main is used for updating the UI, and default is for any long running task or any background thread, and unconfined will not use this type of dispatcher. So basically we will use .io because we want to separate, we want to run this long running task function to a separate thread, so we choose IO. So what does it do? What does this line do? This line will create a thread, a coroutine inside a thread. So like this line will create a coroutine inside a thread, and this thread, this coroutine or thread is IO related. So this will do simply now we will create the coroutine. So we'll create the coroutine. We use the scope dot launch. So launch is the builder for the coroutine function, and here inside the launch function we will create the long running task. Okay, we will also remove the line from here because this long running task is a suspend function and it is inside the IO coroutine scope. So, and we know that all the UI related thing will only happen in main, so we simply remove this line. Instead we will create a log here, log.t, and okay, and we will, what should I say, we will create a tag here that the tag name may be the thread name. So the thread will be thread dot current thread. We want to show the name of the current thread, and it will be, there is a properties name, and we simply put it like response. Okay, not here, like we put here like response. And if we run our app, this long running task will send back to IO thread. Let's see, we run the app, we open our emulator and see the click button, and when I press the button, okay, it's not showing anything, but it's showing the inside the logcat that default dispatcher worker and response. We filter it as response, but one thing is happening, that it's not freezing the UI. The UI is not blocked. You may see that I can click here, I can click here, I can click, and after 2 seconds, every 2 seconds the response is showing in logcat. But if you can remember that at first when we checked, when we click this button, this whole UI freezes for was freezing for 2 seconds. We cannot do anything in the UI. So definitely this is a improvement, and that our long running task is running in the thread, and this is the thread name. Sometimes the default dispatcher worker 2, sometimes it goes to 3, because as we have said that when a coroutine or suspend function is got suspended, it doesn't belong to any particular thread. It can work on any thread, and the thread type we have defined is IO. Okay, that thing is done. Our long running task is running on the background thread. Now we want to get the result back into our UI, but we already know that UI data can only be updated and UI related things can be done only in main thread instead of background thread. So we create a function, and this will be a, okay, we create a function named suspend. This function will be a suspend function, and will be print UI data, and this will take a message, a string type. So string, and we can launch, we can create a scope and launch, but we have another a built-in function for creating creating coroutines, that is with context. So what is the difference between with context and launch? Those are basically same, but with context we are using it with context because we are we want to change our coroutine from UI from this this IO coroutine scope to another coroutine, and that coroutine is in main. So our transition from IO to main, we are changing the context, so we are writing that with context function. So with context it will be dispatchers dot main, as we want to show the data in main coroutine, so it will be main, and inside it we will show the data. So it will be text result dot, okay, first we will call the function. So it will be print UI data from the long running task, and we will send any kind of response or any string. So it will be, in our case it will be response, we will write response. Okay, you can choose anything. So test result dot text, and we will take the first, we will create a new line. So text dot toString, create a new line, and print the message. So okay, let me run this app. Okay, so I click here, and after 2 seconds the response text is appears, and when I click continuously, click, the UI is not blocked, and the response is coming after 2 seconds sequentially, and we can say that we have successfully applied coroutine into our project. So in a nutshell, if I recap everything, that we have a long running task which takes almost 2 seconds to complete the task, as it is a long running task, we have shifted this long running operation to a IO coroutine, and inside the IO coroutine, when the result is ready, we call another coroutine from our this suspend function, and we go to this suspend function, and here we create another coroutine which runs in the main thread, and which simply show our data from IO coroutine to main coroutine. So this is our takeout from the course. This video tutorial is that we have learned the very basic of coroutine. I have a plan to release 2 more videos on coroutine. One is coroutine job and another is coroutine async wait play. So if you want to see these videos, please subscribe if you haven't subscribed, and if you like the video, smash the like button, and if you have any question or any suggestion, please let me know in the comment box. So that's it. Thank you for watching this tutorial. See you in the next tutorial. Thank you.